This is our lesson for Honors Algebra 2, Period 6, on Thursday, August 26th. This is our lesson after Quiz 1-1 to 1-3. We are introducing solving absolute value equations in section 1-4. This handout will be provided to you by the sub, and you can fill in the worksheet as I go through the video. So the first blank line you see on the worksheet, it says the blank of a number x. The words you want to fill in there is absolute value. The absolute value of a number x, written with the vertical bars around x, is the distance the number is from 0 on the number line. The absolute value is either positive or 0, since distance is never negative. For instance, the absolute value of positive 4 is 4. That's because 4 is 4 units to the right of 0. But it's also true that the absolute value of negative 4 is also 4 because it is 4 units to the left of 0. Absolute value is the distance a number is from 0 on the number line. So what we're going to do with absolute value in section 1-4 is twofold. We're going to either evaluate expressions involving absolute value or solve equations involving absolute value. Let's start with expressions in problems 1 through 3. So what we want to do in number 1 is evaluate the expression, the absolute value of 2x minus 3y, if x equals negative 4 and y equals 3. So we're going to input for x, negative 4, which we want to use parentheses with, and for y, the value of 3. And absolute value bars are treated like grouping symbols in the sense that you must evaluate everything inside those absolute value bars, left to right, following the order of operations. So when we look here, 2 times negative 4 is negative 8. And because subtraction is between these two multiplications, minus 3 times 3 would be minus 9. And of course, I'm going to have to, because of space, go left to right. That difference would be negative 17. And that absolute value would then give us 17. Number 2. It says evaluate the absolute value of negative 4 minus the absolute value of negative 2x. And we're going to input for x a positive 6. And so when I evaluate, I would evaluate what's inside the second absolute value grouping symbol, and that negative 2 times 6 is negative 12. And now I'm going to evaluate my absolute values. Because there's subtraction between the two absolute values, I can actually evaluate both simultaneously, and then we would have 4 minus 12, which is negative 8. Number 3. The absolute value of z plus 3 times the absolute value of 5yz, if y is 1/2 and z is negative 6. Now, I do want to point out you do not want to try and distribute the 3 with the absolute value of 5yz, because sometimes it may affect what's happening when you do absolute value. So think of the absolute value bars as brick walls that you cannot penetrate, and you do everything in the absolute value bars first, and then once you've evaluated the absolute value, then you do anything on the outside. So for us, the absolute value of z would be the absolute value of negative 6 plus 3 times the absolute value of 5 times y, which is 1/2, times z, which is negative 6. Now, when I evaluate here, I'm going to deal with the second absolute value bar quantity where I'm multiplying 5 times 1/2 times negative 6. Remember that multiplication's commutative, so it really doesn't matter the order that we multiply. It's much easier to take 1/2 of negative 6, which is really what you're doing when you're multiplying, than it would be to take half of 5 and then multiply that result by negative 6. The other way you might do it is you might think, well, I could take 5 times negative 6, which is negative 30, and take half of it. It's really up to you, but you do want to try to think of how you might do it without always having to rely on a calculator. So maybe I would take half of negative 6, which is negative 3, times the 5, which is negative 15. So I have the absolute value of negative 6 plus 3 times the absolute value of negative 15. Of course, multiplication will come first, so I will evaluate the absolute value of negative 15, which is 15. And then I would take the absolute value of negative 6. I might have done that even in the same step. And again, I'm missing space here, so I'm just going left to right. And I end up with 6 plus 45, which is 51. All of this can be found worked out in Canvas. If you want to look there, you can see it a little more succinct when I write with a pencil or a pen than I do with my Apple Pencil. All right, so that's evaluating expressions with absolute value. Now we're going to look at equations. You can see in number 1, we have the absolute value of 6x minus 3 equals 15. Well, if the absolute value of this quantity equals 15, we have to remember to have an absolute value of 15, we could either be 15 units to the right of 0 or 15 units to the left. As a result, that means we really need 2 equations to solve for this equation. One equation expresses when we're 15 units to the right. That would be 6x minus 3 equals positive 15, while the other equation is when we're 15 units to the left. So I am setting that quantity equal to negative 15. Most students forget that second equation, but that's critical because there's really 2 possibilities here when we're talking about having an absolute value of 15. So solving the equation on the left, I'm going to add 3 to both sides. That gives me 6x equals 18. Divide both sides by 6. That gives me x equals 3. In the other equation, when I add 3 to both sides, I get negative 12. And when I divide, I get negative 2. It's always a good habit to check our answers. If I plug 3 back in for x, 6 times 3 is 18, minus 3 is 15, and of course the absolute value of positive 15 is 15, whereas if I plug in negative 2, 6 times negative 2 is negative 12, minus 3 is negative 15, and the absolute value is also 15. How about number 2? Go ahead and try this one. You're going to write 2 equations. I'm going to do number 2 down here. So I have the absolute value of 2 minus 4x equals 10, meaning 2 minus 4x equals positive 10, or 2 minus 4x equals negative 10. 10 units to the right of 0 or 10 units to the left. In the first equation, I'm going to subtract 2 from both sides. That will give me positive 8, which means x would be negative 2. In the right equation, when I subtract 2 from both sides, I'd have negative 4x equals negative 12, which means x equals positive 3. Interestingly enough, the same solutions I had in problem 1, but a totally different equation. And again, you could test those results, but you're going to find that the equation on the left produces a positive 10, and the absolute value would be 10, while the 3 would produce negative 10, and that would have an absolute value of 10. How about number 3? Well, in number 3, we have this extra operation of plus 9 on the left-hand side of the equation. The equal 0 might throw people off, but the key really is when you solve an absolute value equation, you want to isolate the absolute value quantity. In this case, the plus 9 has to be dealt with, and we're going to subtract 9 from both sides, which would give us the absolute value of 5x minus 6 equals negative 9. This is where it's really important that you are alert to what the absolute value quantity is equal to. Remember, absolute value is distance and must always be positive. So anytime you have a negative, that should be a flag to you that that's impossible. You can't have the absolute value equal a negative 9. So if you're alert, you're just going to say at this point, no solution. If you're not alert, you might, and I'll put an arrow down here, you might go off and do 5x minus 6 equals negative 9, or 5x minus 6 equals positive 9. In this case, 5x would equal negative 3, so x would be negative 3/5. Over here, when we add 6 to both sides, 5x equals 15, x equals positive 3. Again, thinking 2 answers seems reasonable, but if you test those solutions, that's where you're going to run into trouble. If you plug in negative 3/5 to the original equation, 5 times negative 3/5 is negative 3, minus 6 is negative 9, and the absolute value of negative 9 is not going to be negative 9. It would be positive 9. So that doesn't check. And if you plug in positive 3, 5 times 3 is 15, minus 6 is positive 9. Again, the absolute value will not be negative 9. So that should lead you to the same conclusion, that there's no solution. But why do all that work if you don't need it? It's much easier to be alert in the first place. All right, number 4, final example. Just because we have the absolute value of 8x or 8 plus y in absolute value bars equal to 2y minus 3, you might think, well, you can't solve it because it's not like 1 or 2 or 3 where the absolute value quantity equals a constant. No worries, we don't know the value of y, so we can't presume it's positive or negative. We actually solve 2 equations. One equation, 8 plus y, would simply equal 2y minus 3. The other equation, you would say 8 plus y, I'm trying to think, I'll go right down here. Oops. You would have, I'll go right here, 8 plus y equals the opposite of the quantity 2y minus 3. That's like taking the opposite of the constant. So in this one, 8 plus y would equal negative 2y plus 3. And I'm going to get y's on the same side, so I would add 2y to both sides and subtract 8 from both sides. That would give me negative 5, and y would be negative 5/3. Over here, I would subtract y from both sides and add 3, so I get y equals 11. So I need to check back here in the original equation to see what works. So if I plug in 11 on the right side, now this is what's key. You want to plug in on the right side because all we need to do is figure out whether that quantity is positive or negative. Remember, the absolute value can't equal a negative, so that wouldn't work, but a positive should be fine. Well, when I plug in 11, 2 times 11 is 22, minus 3 is 19, that actually checks, so that's valid. That just means the right side is a positive number, and if I test it and plug in 11 for y, 8 plus 11 is 19, and the absolute value of 19 is 19, so it works. Negative 5/3, on the other hand, when I plug that in, 2 times negative 5/3 is a negative number. I don't even need to find what it is. It's a negative number. Minus 3 would be negative. Well, it's impossible for the absolute value to equal a negative, so we toss that out, and this equation only has one solution, 11. All right. The last thing I want to say is sometimes people think that they can distribute. It would be really a problem to distribute that negative 3. Instead, what you want to do to both sides is divide both sides by negative 3 to isolate that absolute value quantity. On first glance, this equation might not seem solvable because of this negative 9. But because we have to divide by negative 3, that does produce a positive 3 on the right, and we actually do have solutions. I'm not going to solve it, but that's something I wanted to point out. It's also true that you can have the absolute value of something equal 0. This is okay because absolute value can equal 0. 0 is its own opposite, so you wouldn't need two equations, only one where it equals 0, but it is possible. All right, please check Canvas, but you should be doing for your assignment, for homework, page 30 to 32, numbers 14 to 40 even, the E stands for even, 31 and 58. I think that's 14 or 16 problems. Not too bad. All right, we'll see you on Friday. Have a good day.